Hey everyone, let me open with a simple question I would really like you to think about. What separates a programmer who writes code to a professional engineer who builds system the words depend on? The answer is pretty much simple. It's not the experience, it's not the technical depth. It's the understanding and the application of this in a disciplined way of the technical standards. My name is Mohammad Rizwan, and today I'll take you from the mindset of a developer writing code that works to a mindset of a professional engineer whose system must perform safely, reliably, and professionally in the real world. By the end of this session, you will be able to navigate ISO series like a professional and understand how standards like ISO 13485 and other operate in real world. So there are commonly known standards IEC, IEEE, CE, ISO, DIN and PILS. So they are the six organizations that wires the rule of the professional engineering. Here is the thing. Now we go deep on ISO, the International Organization for Standardization. ISO publishes standards across every imaginable domain. Today we will only focus on some critical families like the mechanical, electrical, integrated or mechatronic system and the medical systems. Each family has series structure and understanding that structure is how professional navigates the standards landscape. By the end of this section, you will have a map that serves throughout your entire career. So here we are on the main part of this session, the standards, what actually means. So starting from the mechanical side, in mechanical ISO provides four different series that are basically very critical. The first one is ISO 9000 series that is basically related to quality management system. And the most important one from this series is ISO 9001. It is basically defines how manufacturing organization must control their process to deliver consistent repeatable quality. If any company has one certification of the wall, it is probably the one. The second one is ISO 12000 series. This is related to machinery safety, and the most important one is ISO 12100, and this is the starting point for our new machine design. It provides the risk assessment, identification of hazards, and application of reduction methods. If you are designing a new machine and you are not aware of these standards, you are not designing it professionally. You are guessing. And the other one, the third one is ISO 14000 series. It is basically related to environmental management. And the last one is ISO 286 and 1101. This is basically the most important one in the mechanical engineering. This is related to geometrical dimensioning and tolerance. And this is the standards that is basically, you can say that the language of mechanical drawings. If you want to understand the drawings, you have to know these standards and you have to apply these standards to understand the drawings, to make the drawings, and to make a professional one for your system that should be always in the system. Okay, so moving on to the electrical standards. Electrical standards are the one in which ISO and IEC standards overlap significantly. Let me walk through these. The first one is ISO 81346. This is essential for an engineer designing industrial electrical systems. It defines how you label, reference your components in the schematic. This is the standard behind the E-plan designing software, and every professional electrical drawing you will ever read or you will ever produce. Without this, your schematic is an art project, not an engineering document. The second one is IEC 6364. This is basically the installation guide, how your electricity will be distributed in buildings or in industrial plants. Voltage level, protection schemes, and wiring designs all lies and defines over here in this standard. The other one is IEC 61000. This is related to electromagnetic compatibility. Your electronics must not interfere with others and must be immune to interference. This is why your device is needed the EMC testing before it's certified to CE standards. Failing EMC is one of the most common reason products are rejected before even entering into the market. The other one is ISO or IEC 80000 series. This is basically related to units and the quantities. These standards tell how you are basically defining the units and quantities in some professional and engineering documents. So this is, we can say that it is the mathematical language for all engineering. So these are the electrical standards that are mainly very important for any electrical engineer that is converted, that wants, who wants himself to be converted as a professional engineer. So the next one is electromechanical and mechatronic standards. Mechatronics sits in the intersection of electrical, mechanical, and software or computer engineering, and its standards reflect its complexity. So I'll try my best to make it as slow as possible so that you can digest as I speak. So the first one is ISO 13849 standard. This is probably the most important safety standard for machine builders. It defines performance levels, PLA the lowest level and PLE the highest level. These levels tells you exactly how reliable a safety function must be. An emergency stop on a press brake operating near humans. This is probably a PLE, the highest level, and the status indicator light, and this is probably a PL level A. These standards give you a systematic way to calculate and verify the required level. The next one is IEC 62061. This does the same job using the safety integrity level SIL 1, 2, and 3. These two standards are now harmonized, meaning either can be used to demonstrate compliance with the EU Machinery Directive. Understanding both makes you exceptionally valuable in any industrial engineering team. The next one is IEC 81346. It's the same as we discussed in the previous slide. It's appear again because in mechatronic system the documentation layer is very important and critical. Your E-plan schematic, your PLC program, and your mechanical assembly drawings must all use a unified reference system. ISO 81346 is what makes that possible. So this standards makes your documentation aligned on every level. The next one is IEC 62061. This is for you if you are looking for safety system, and this is probably and primarily electronics and programmable. ISO 13849 that we discussed earlier includes mechanical, electrochemical components in practice. Modern systems use both. So these are the electromechanical and mechatronic standards that are very important for you to understand, because these are the standards that builds the core for any professional engineering design, and this makes you valuable at anywhere. So the most important one, the firmware and software standards. As we know, modern machine runs on firmware, and firmware, like hardware, must meet standards to be trusted in production. There are three main and important standards for these that will be discussed over here is 12207, 25010, and 29119. The first one is 12207 is basically related to life cycle process of software. It tells how your software will be managed from the first requirements all the way to commissioning. Requirements, architecture, coding, integration, testing, maintenance, every phase is defined over here in this standard. The next one is 25010. This defines the square quality model. This gives you measurable quality dimensions for your firmware reliability. How well does it handles fault? What's its performance efficiency? How lean is the resource usage? What's its maintainability? How modular is the code? These are not some vague goals. These are the characteristics you can test, measure, and certify, and all these are covered over here in this standard. The last one is 29119. It is basically the software quality testing standard. In safety critical firmware, it is not enough to test the happy path. Every code path in a safety function must be exercised. 100% path coverage for safety loop is not an aspiration, it's the requirement. And this standard works alongside 21434 for the cyber security in connected systems. These all are very important standards in software and firmware area or firmware domain. So these are discussed over here. So as we wrap up, I want to leave you with one thought that I hope stays with you long after that. The gap between the programmer and a professional engineer is not the years of experience, it's not the number of projects completed, it's the decision, a conscious decision to understand that your code will live inside a global regulatory framework. The real people will depend on what you build. The safety, quality, compliance are not constraints on engineering. They are engineering at its high level. ISO standard give you blueprints. They give you they give your clients confidence, and they give you as a professional the career passport to work anywhere in the world on any system that matters. Thank you. Hope you enjoyed that session and hope it will be very beneficial for you guys.